right, this is our last review for your exam, which will be in the next lesson, lesson 178. I want to begin by taking a look at your homework on page 585. You answered questions 1 through 16. Let's take a look at that homework together. Number 1 says, what type of graph is the statistical representation of a 5-number summary? And that is a box and whisker plot. I'm going to go in a little bit more depth there in just a moment. Number 2, what are the 5 numbers in a 5-number summary? And that would be the minimum, the smallest value in the data set, the first quartile, the median, which of course you know is that middle value when you rank the data, the third quartile, and the maximum, which is your largest value. Remember, you find the range by subtracting the maximum and the minimum. Number 3, which quartile is the median of the upper half of data? Well, that would be the third quartile, right? So your minimum's the smallest. Your median, if you were to average all the numbers in between, or find the median, excuse me, of those numbers, that's your first quartile. Then median up to the max is your second half of numbers. The median of that set is your third quartile. And again, the box and whisker goes from first quartile to third quartile with a box, puts a line where the median is, and then extends the whiskers out to the ends where the minimum and maximum are. Number 4, what type of bar graph has multiple categories on the same bar? That's the stacked bar graph. What's the name for the difference between largest and smallest values in the listed data? We looked at that already. Range. Number 6, what type of graph is used to relate the value of individual categories to the whole? That relationship to the whole is the circle graph. Number 7, what type of graph shows changes in data over time? That is the line graph. What 2 types of graphs group data into classes? Remember the stem and leaf plot. It isn't necessarily a graph per se, but that's one of the answers here. Where you have all your numbers in the 30s, the 40s, the 50s, the 60s, the 70s. You put the 3, 4, 5, 6, 7, and then all the units, digits, if you will, off to the side. That kind of groups them into categories. The same kind of thing happens with a histogram. Okay, all the people who were in the 30s, okay, here's all the values that were in the 30s. Here's all the values in the 40s. So it just kind of shows groupings, if you will, frequency within groups. And the number 9, for the data value 56, what would the stem be? Well, the stem would be a 5, and the leaf would be a 6, perhaps in a set of all different other leaves from values that were in the 50s. And we'll look at some of those here in just a little bit. Numbers 10 through 16, practicing with algebra. Number 10, you're multiplying monomials. Remember, sign, number, letter. And remember, when you multiply like bases, you add the exponents. So you've got a -10, d to the 6th, n to the 9th. For number 11, you're going to FOIL those 2 binomials. Your first gives you an 8k squared. Your outer is a -5k. Your inner is a positive 32k. And we're going to combine the -5 and positive 32 to get a positive 27k. Remember, it's first, outer, inner combine, and then last. And at the end, a -20. So again, your answer, 8k squared, positive 27k, -20. For number 12, we're dividing, and remember, sign, number, letter again. But remember, when you divide like bases, you subtract the exponents. And wherever the bigger power was, top or bottom, once you've done the subtraction, that's where the answer stays. So 12 divided by 4 is 3. But you've got a p to the 5th divided by a p to the 8th. We're going to subtract 8 minus 5 to get 3. Bless you, but those 3 p's are in the denominator. And then also, we've got an m and an m squared. We'll subtract the exponents, gives you m, but in the denominator. So 3 over p cubed m is your answer. For number 13, you have a polynomial divided by the monomial. You're going to do sign, number, letter 1 time. Then you're going to do another sign, number, letter. So -5y to the 4th divided by 5y. Sign, number, letter is -1y cubed, or just -y cubed. Then you've got to do another sign, number, letter, positive 10y divided by 5y, to get positive 2, and the y's cancel. So -y cubed, positive 2 is your answer. For number 14, you're going to factor out the common monomial. Remember, you're going to start by looking for a number that's in every single term, and then you're going to see, are there any letters in every single term? In number 14, there is a 7 that's common, and that's it. So you're going to write down the 7, and then in parentheses, 2a, positive 3b, -7c, when you divide out the 7. Remember that factoring is division. So as you factor out a 7, you're dividing everything by the 7. Again, your answer is 7 times the quantity, 2a, positive 3b, -7c. For number 15, there isn't a number that's common, but there is a letter. In fact, there's an a to the 4th power. Remember, we don't just want to pull out an a, we want to pull out as much as we can. And there's at least 4 a's in every single term, so we'll pull out a to the 4th. As we divide it out, remember, subtract the exponents, we'll be left with a to the 4th times the quantity, a squared, negative 9a, positive 11. And then on number 16, you've got a 6 that's common, and you've got a d that's common. We'll pull out 6d times the quantity, d squared, positive d, negative 8. All right, hopefully you did well on that homework. If you would go and flip back now to page 581, and we're just going to kind of move quickly through this review time, talking about some different concepts here. Looking at page 581, that graph at the top, of course, we notice a bar graph. Notice the bars get progressively longer. What this means is that the data set has been ranked from smallest to largest, and then the smallest value first. Okay, unless there's some other order, remember, like Monday, Tuesday, Wednesday, Thursday, Friday. Okay, you wouldn't rewrite them so that their values are in order. You keep them in chronological order. But here, just get them bigger, bigger there. You can clearly tell by looking at it, the biggest city in the world is Tokyo, Yokohama. You can clearly tell that this is supposed to show you the 10 largest cities in the world, so you wouldn't look and say, wow, Sao Paulo must be small because it's the smallest one on here. Well, no, it's the 10th largest city in the world. You notice the data labels, okay, the axis labels, axis titles, as they're called, listing out the population, so you know that each of those numbers means millions of people. Notice they've labeled the major grid lines, every 5 million. And the minor grid lines are there as well. There's 4 of them in between, so that every grid line is 1 million people. Makes it easy to read the graph. And not that they needed the axis title there, but cities, just in case you were wondering what those names were for. Interesting, there's only 1 U.S. city on that list. Most of these cities, you'll notice, are in Asia. Beijing, Karachi, actually I don't know if Karachi is in Asia or not. Shanghai is, Delhi is, Seoul is, Jakarta is in Indonesia, so yeah, that would be as well. Tokyo, Yokohama, so 6 of the largest cities in the world in Asia. No surprises, that's where most of the world's population lives. Right? China, India, the 2 most populous nations in the world. We look down here, we see another circle graph here, okay, showing parts to the whole, or percentages. And in fact, they actually use percent labels on here. Different elements in the Earth's crust. Obviously, we can tell just by looking at it, the most abundant element is oxygen. Now, not the least isn't calcium, okay? It says all others are kind of lumped in at 9%. So there's other little ones that aren't even worth mentioning, but oxygen, silicon behind that, kind of see that there. If you wanted to know how much is oxygen and silicon together, well, you add them together to get your 75%. So you can even add portions there. Look at the next page. We've got what I would call a curved line graph there on page 582, because it follows one progressive motion, if you will, actually from your perspective this way. But you see the population in the U.S. Kind of exploding. Right around 1850, it begins to shoot up. That's as the industrial age begins. Immigration begins to happen on a greater scale as there's now opportunity in the United States. You can kind of see a projected trend. I mean, if you were to want to project out, okay, that graph ends in 2000. Well, we're in 2020-ish now, 2021 at time of recording, but man, how much must the population be now? And we are around 330 million. I'm not sure if you were to keep tracking that over the next 20 years, that's probably about right. So continue to increase at a steady rate. But again, you see those axis titles, the year, notice they do every 50 years, and then the population, notice in millions of people, so you don't have to write all those zeros. You see box and whisker plots there. For number 14, note the box and whisker plot. Your median, remember, is that middle line. It looks like it's right about 65. Notice your minimum appears to be, what would be that, 22? Maximum up there about 128. And then your first quartile, about 44, your third quartile about 86-ish. It's a pretty even data set, right? Everything's pretty evenly distributed there. You do have a rather long whisker on the upper end going to the maximum, so it tells you very possibly the maximum is a bit of an outlier, but otherwise pretty evenly distributed data set there. Looking at the box and whisker, take just a moment, if you would, to draw the box and whisker plot for let's do number 16. So let's just do number 16 very quickly and draw that box and whisker plot. Pause the video just long enough to do that. All right, so on number 16, hopefully you started by drawing a small line at 4, drew another line at 9, drew another line at 13, another line at 19, and another line at 24. You mark a little line for each of those 5 numbers. Hopefully then drew a box from 9 all the way around to 19 and boxed in that median line. And then drew whiskers out to the ends. Okay, so pretty straightforward there. We did look at how you can compare 5-number summaries and box and whisker plots. We can see that the Smiths on their best day had more mail than the Johnsons, and on their worst day had less mail. So greater variety in the amount of mail that shows up in the mailbox for the Smiths, but notice their medians are the same, so pretty much they receive about the same amount of mail, and it's usually all junk mail. Looking at the stem and leaf plots. Number 24, go ahead and draw that stem and leaf plot. Pause the video while you do so. All right, let's look at the answer to number 24. They started you with your first stem, which should have been a 2. You should have drawn leaves of 0, 2. You had to include the stem of 3, even though there were no leaves. Now, one might say, whoa, does that mean that 20 and 22 are outliers? Well, an outlier has nothing else close to it. They're close to each other, so there isn't technically a low outlier there. For the 4 stem, should have had a 1, 1, 5, and 7. And then for the 5, which was your last stem, should have had leaves of 0, 1, 2, and 9. From there, you should have been able to tell 41 is clearly the mode, though not by much. There's only 2 of them, but it's still the mode of the data. If you were estimating where the median would be, it'd probably be right around the 41, maybe 45, okay? Because that would be kind of in the middle of the set. If you wanted to tick off the median, right, you could talk up the 20 and the 59 and go from there, whatever. Looking at the stem and leaf plot for biology, final grades. We see that there's one person who failed, got a 69. And one person got 100. Again, is that an outlier for the 100? Well, it's only 4 points off the 96. I don't know how to call it an outlier. And then 69 is only 3 points off the 72. I wouldn't exactly call that an outlier either. Most students clearly landed in what grade range? Yeah, hopefully you said the 80s, okay? More grades in the 80s than anything else, which means most people are making Bs. In fact, the most common final grade in the class, just look at it, it kind of pops off the page at you. Yeah, it would be the 85, that mid-range B. So while we say Cs are average, well, apparently not for this class. Bs are pretty much the norm. Several A's, right? You've got, what is that, 6 different 90s and 100, so 7 different A's in the class. A few C's, and then, of course, the F there at the bottom. Looking at the histogram. Notice, again, looks like a vertical bar graph, but the bars touch each other. Now, quick refresher on the histogram. The first box, the first bar, is 0 to 10. But remember, the 10 is actually the beginning of the next bar. So really it'd be 0 to 9 minutes, and since the time is in minutes, the 0 to 9 minutes 59 seconds technically. The next bar is from 10 minutes to 10 minutes 59 seconds. Then 20 minutes to 20 minutes to 29 minutes 59 seconds, and so forth. Most people, their commute is in the teens range, right? 10 to 1959 for their commute to work. Very few people for this particular employee grouping have commutes over 40 minutes or 40 minutes and above. Most people, their commute also isn't less than 10 minutes either. Most people, the big group of people, is between 10 and 40 minutes. That's pretty easy to see. We did look briefly at the scatter plots. If you look at page 584, you can see that there's definitely the dots seem to be trending slightly upward. They're pretty spread out, so I would say there's a weak positive association there. You look at number 39, there's again a weak positive association. Number 40, you would notice a strong negative association. The dots are going downward and they're pretty tightly connected there. Really all I wanted to go into on graphing, there won't be a lot of graphing on the final exam, and frankly, there won't be a whole lot of graphing later on in high school math. What there will be a lot of graphing, though, in is not you drawing graphs, but you seeing graphs in newspapers, on websites, when you look up statistics for different things. And I think you probably should. You're going to hear all kinds of things in the news one day, and you'll want to look things up for yourself. The news tends to slant things the way they want to slant things. And so what I have found myself doing a lot in recent days, we've had a pandemic recently where all kinds of different numbers are thrown at you. You can make numbers say whatever you want. Okay, I want to look at the cold hard numbers and draw my own conclusions. Usually you'll find those numbers on graphs. And you need to be able to read the graphs and see what is the graph actually saying. So kind of a real life thing, just being prepared to be an educated adult. I will say standardized testing does include graphs, but never graph making them, always reading them. So that's perhaps the biggest need you would have as far as graphing goes. Let's get back to algebra now, because that's what you're going to have next year and the year after. That's what really in all through. I mean, the algebra never goes away, even in geometry pre-calculus. You still use algebra, and a big part of the exam as well. If you would, look at numbers 41 to 55, and I kind of went over this when we looked at the homework, but remember, addition or multiplication and division is sign, number, letter. Remember, if the signs are the same, you get a, hopefully you said positive. If the signs are different, you get a negative. Very good, Hayden. All right, I guess y'all know this. I could be asking you guys. We got my study hall still in here, even though my students are out. Multiplying numbers, you just multiply them. Like, do what you know to do. Dividing numbers, remember, you can't always divide. Like, you can't divide 10 by 6. It doesn't work out. So I said, remember, if you can't divide, since we show division with a fraction bar anyway, treat it like a fraction and reduce it. 10 divided by 6 becomes 5/3, because you would simply reduce it down. And remember, when you multiply like bases, what do you do with the exponents? Add them. And when you divide like bases, what do you do with the exponents? Subtract them. When you subtract them, wherever the bigger exponent was, that's where you leave the answer as well. I'm not going to have you do all of 41 to 55, but if you would, do numbers 41, 45, 47, 54, and 55. Pause the video for a moment while you work these 5 problems, and then when you're finished, go ahead and resume. All right, let's see how you did on these 5 problems. Number 41 should have multiplied by adding the exponents to get m to the 12th. For number 45, should have subtracted the exponents as you divided to get r cubed t over u. You'll notice the s squareds cancel completely, giving you s to the 0. And of course, anything to the 0 power, gentlemen, equals 1. Anything to 0, it's okay. They messed it up too watching the video a minute ago. They said it, I don't really know, I'm just making it up. But anyway, yeah, s to the 0 would become a 1, and you work a 1 as a factor in there, it doesn't really matter. So we just say it cancels, remember, so r cubed, the t has no friends, but just because it has no friends, right, Glenn, doesn't mean it doesn't exist. And then the u in the denominator also had no friends, but it still exists, leave it in the denominator, r cubed t over u. I'm going to have fun with you next year. Number 47, remember the signs are the same, so that gives you a positive. 18 divided by 3 is 6, and m squared divided by m is m to the 1st. For number 54, you're going to divide sign, number, letter once, and then sign, number, letter again to get a 3v cubed, positive 4v squared, the binomial answer. For number 55, you're going to have to distribute sign, number, letter once, then multiply again a sign, number, letter a second time to get negative 45 k to the 6th L, positive 30 KL squared. Hopefully you did well on those. Want to practice as well this idea of FOIL and factoring. We practiced in the homework. I already kind of reviewed it. I want you to practice now with numbers 61, 65, and 67. 61, 65, and 67. Go ahead and do those 3 problems. Pause the video while you work. All right, let's take a look at your answers to number 61, 65, and 67. Number 61, when you FOIL, first, 15j squared. The outer inner combine for a positive 24j. That's a negative 6j, positive 30j, and then your last gives you negative 12. So again, your answer, 15j squared, positive 24j, negative 12. For number 63, you're factoring out the common factor, and there's a 3 that's common, or it should be 65, excuse me. Number 65, there's not a 3 common, but there is an a that's common, and that's all that's common. So you factor out the a, and in parentheses it leaves you with the quantity 3x, positive 5y, positive 7z. And then number 67, you should have noticed there's a 2 and an x common, so factor out 2x times the quantity 3x, positive 5. All right, you'll notice that if you turn the page 586, the last review is the last chapter that we worked on in class. We did not do chapter 12. So chapter 11, you just took a test on about 5 or 6 lessons ago. You should remember that fairly well. If you want to skim over it and just refresh your own memory on things, you certainly may. But for our purposes, this will conclude our exam review. You will have your exam in your next lesson. So as needed, if you want to work some problems that we skipped in these last several review lessons, that's certainly not a problem. If you do work some problems and you're not sure if you worked them correctly, you want to find out where your answer is correct, certainly you can email those answers to me. Just take pictures of the pages, email me, and I'll get back with you. But that'll conclude our review. Hope you do well on your exam in the next lesson.